In this third item, we're asked to find a shear moment diagram for a cantilever beam that has a downwards distributed load across the entire length, a frowning face moment of 99 kip feet applied at A, with reactions at A that are upwards of 19 and at B upwards of 32. Of course, the keys are going to be that the slope of the shear diagram is given to us by Q, which of course means that changes in shear will be given to us by area under the loading diagram. And then likewise, the slope of the moment diagram is given to us by the shear, and therefore the change in moment will be given to us by the area under the shear diagram. All right, so let's get our units in first. Our shear is in kips. We start off at 0. We have a reaction that is a point load, and that goes up to 19 kips. That's positive because we're starting at 0 and follow the direction of the arrow. Now you might ask, what happened to the couple? Well, the couple changed the reactions, but it's not directly shown in the shear diagram, only in how it affected the reactions. And then as we march across from A to B, this area under the loading diagram will give us the change in shear. And notice that will be a negative 1.5 kips per foot times 24 foot, or minus 36 kips. 19 minus 36 would equal minus 17. So we want to try to get relatively close to scale from our previous selection of that 19 equaled 1 inch, so 17 equals just slightly less than that. And there's our minus 17. And then 32 kips is our discontinuity in the shear diagram that immediately jumps the shear from minus 17 up to a net of positive 15. Note that 32 kip difference. And then we close off at the same slope. We hope that we get a negative 15. Sure enough, 1.5 negative times 10 would be minus 15, and that would take us off to 0. And if that's all we wanted, we could be done, but usually we're going to want the shear diagram too. So we need to find out then where the 0 moment is located at. And so notice that range of 19 over 36 is the same as that x distance is to the total of 24 feet, and that will tell us that x is equal to 12.67 feet. That'll tell us that the other side that we have 11.33 feet. That will be important for us because that's going to tell us something about a local maxima or minima for the moment. So we'll go ahead and draw that line down here as well. Our moment will be in units of kip feet. It's going to start off at 0, but then have this discontinuity of 99 kip feet. So it starts off immediately right there. We're at a first order curve on the shear diagram. We're going to integrate that and get a second order curve down below, and it looks like that will be the case in each one of these segments. We have a smoothly varying shear, so we're going to have a smoothly varying slope on the moment diagram. Notice I'm drawing a concave down. I haven't put it on there yet, but I've sort of indicated that it's going to be because I can tell the slope of the moment diagram given to us by the shear. We start off at a big positive slope. We're going to end up somewhere at a 0 slope, and that change in that moment will be given to us then by this area of the triangle. So 1/2 of 19 times 12.67 feet, and that will equal about 120.3. Subtract off the 99, and we end up at about 21.3. So right about there. So that gives us one point where we're going to have 0 slope. Notice I'm not going to get too much more in here because it's I want to try to do a good job of getting this to a reasonable scale, and that means I got to go figure out what's going on here. 1/2 of minus 17 times 11.33 is going to give us, well, I'm not sure what it's going to give us. Let's calculate it. 17 times 11.33333 divided by 2, 96.333 plus the 120 point, oops, sorry, no, that's not either. That's right there. That was a net of 21.333. And that gives us a net of minus 75. So about there, minus 75. Let's check something before we go do all the drawing, because out here, this change in moment will be 1/2 of 15 times 10, and that equals a plus 75. Hey, that's great. That's going to take us right to 0 with a second order curve. And note that it is going to put us with a nice little horizontal segment right at the right end. Bam, there we go. There's our second order curve ending up at minus 75. We need to end up with 21.33 here at that point. And if you really want to have some fun, go be a little bit more careful here. Figure out where you have 0 moment. It's going to be symmetric here. This little area needs to equal 21.33, and that's got to be equal then to 1/2 of our delta x that we're working with times, the slope. See, this gets kind of, sort of interesting and tricky here. That's going to end up being, well, let's see. What's that going to be? Well, that's going to have to be set up. Let's see, that's our delta x in there, and that little height is 17. Let's see, that's delta x is to 17 as 11.33 in there, and what we're going to find out is that therefore delta x is 5.33 feet, right? And so that puts us, right about in here, right about in there. If we really wanted to get this perfectly nailed down, we'd just get the function and plot this in Excel or something. That's not really what we want to screw around with. We just want to get this as best we can notionally in here, rather than trying to have it plotted perfectly to scale. This is symmetric about this point, so I'm going to take my French curve and turn it around and try to get that reasonably close to symmetric and nice and smooth. This is what we want. And maybe 0.533. Let's just check to see if I really did do that math correct over here. That 2 times 21.33 times 17 divided by 11.33, and take the square root. I didn't do that math right. Alright, that might need a little bit deeper investigation about where that is. I'm not confident of that number yet. So let's just work it out. And if we work it out, what do we got to do? We got to really know what the slope of this little guy is. That slope of that line is, that's associated with this 1.5 businesses, isn't it? So, that's kind of an interesting point here. Mx plus b, and so that slope is 17 divided by, that really works out. That slope should be 1.5, and I think I got the ratio of those two flip-flopped. That should be 1.5, 17 over the 11.33. Now I think we'll find out that this thing is going to work out properly. There we go. There's our 5.33. I just got these two flip-flopped back over there. So yes, check mark.